Without the use of a calculator, because we don't need one. So with logarithm equations, you're going to get a basic idea. You get a basic generic setup of y equals log base b of the quantity x minus h plus k. Now, in our case, we're in logarithms, we do not graph parent and shift. We go right for it, okay? We go right for it, because what we're going to do is a lot of mental math when it gets to this. Now, what I want you to remember is logarithms and exponential form are inverses of one another. We graphed exponential form a week or so ago, and exponential form did this, and it reached to a horizontal asymptote. Now, logs are the inverse of them, which means if there's a horizontal in an exponent, what will it be with logs? Vertical. Also, trees are made of logs. Trees grow vertically.
Speaking of trees,
I don't remember. Yes, ma'am. Yes. It'll all be mixed in. So what happens here is that you get a vertical asymptote at your h value. You will always have a vertical asymptote at x equals h. Now, one thing that you will see with logarithms is that the h value will always be captured in a parenthesis. It will always be put in parentheses. If there's no parentheses around the x or the x part, that means your h value is 0. Okay? They will always, h will always be grouped. K won't be. So you might see something where it writes it out as one of those has an h, the other one doesn't. The top one has the h because it has parentheses. Correct. Yeah. All right.
Do you know if x equals h, how does that work? Like, is it just like 1 minus 1?
What do you mean?
Like, if x equals h, like, would it be just x, like 1 minus 1 would be the asymptote?
Ah, what happens here is what's your h value here?
Negative 2.
Ah,
it's 2.
With
2.
positive 2.
So your asymptote's at 2.
Oh, okay.
That's it.
All right.
Okay. That's all it is. Whereas, remember, in exponential, our asymptotes were at k. Now they're at h. The domain. The domain for logs is always x is greater than h. They're always moving right. They're always moving right. So the domain is always to the right. There is a half-credit class in college called drawing set notation. So as you get along further on, I think next year, Ms. Denny uses set notation a lot more than I do. So that states domain values such that Jay Leno's face looking left, x. That's what it is. The domain is Jay Leno's face looking left, x. The vertical line means such that x is greater than h, Jay Leno's face looking right.
How would that work? Like, if you're going to use a negative 2,
The 2 example in that one, I would say that my domain would be D, Jay Leno's face looking, oh, that was bad. Jay Leno's face looking left, values of x such that x is greater than 2, and then Jay Leno's face looking right. That's it. That's a tough class. It took me a while to get good at it, but yeah, you actually had to sit there and draw Jay Leno's faces a lot.
Who decided which Jay Leno's face?
Because it kind of looks like it. Why do you have to be so mean? Range. Your range is always all real on these. There's no, because it's just a vertical asymptote, so you're domain restricted, but you're not range restricted. And then there's 2 ways that these look. The graphs for logarithms are always moving to the right. It's either moving up and right if b is greater than 1, or down and right if b is less than 1. So the graphs are either if b greater than 1, it's doing this. If b is less than 1 but bigger than 0, it's doing that. And that's the only directions that those two can go. There is no inverting them or anything like that. Not like with exponentials, we had growth, decay, all that kind of stuff. You can have negative growth, you can have negative decay, things like that. That's the only way that these work. So far, so good up? All right. Let's graph it. So we have log of quantity x minus 2 plus 3. So I'm going to go right back to the example you had earlier. What's the base that you don't see? 10. This is base 10, so this is what you don't see. So here's what we're doing. What we're going to try and do is, first of all, the easiest thing to plot is going to be your asymptote. Your asymptote here is going to be at x equals 2 for your vertical asymptote. Okay? So I plot that to start. Okay? Now in the back of my mind, what I need to do is I need to generate and pick values of x so that I can create these two properties. That's how we generate x's and y's. You're picking numbers that make sense. So this is log base 10. Log, I'm just going to put a 10 here to remind us. I need to pick some number here that makes the jump in parentheses 10. Well, nope, we don't do parent functions with these. I'm picking a value, I'm picking some value of x here that will create the property of log base 10 of 10. I don't want to, I'm not going to, because what's 10 minus 2 though? It has to be 12. What I'm doing here is I'm creating these properties to simplify the logs. We use these two properties to create two ordered pairs. That's all we need, because we know the direction of the shape. So I'm going to pick a number, 12. There's my value of x that I'm choosing. So what's log base 10 of 10? 1. What's 1 plus 3? There's your ordered pair. There's an ordered pair. I'm going to pick a value of x to create log base b of b equal to 1. I also want to pick a value that creates this one to become a 1. I'm going to pick 3. So I have log base 10 of something minus 2, and I want this in parentheses to equal 1. So I pick 3. And what was it, plus 3 at the end? So log base 10 of 1 is how much? 0. What's 0 plus 3? 3. So this ordered pair would be at 3, 3. And it has to be doing this.
So we need 2 points.
Yep. Because you know the direction because there's only one of 2 directions. It's either going to be moving up into the right or down into the right. So if you get 2 points, you just connect them with the curve. Go. You can find other pairs. You can find other ordered pairs if you want by using the inverse properties, but you don't need to. You know, I could have gone through it a lot more again. Yeah.
Okay.
Yeah, there's really not that much craziness to it.
He's not done yet. He's gonna throw some.
Of course, sir. Okay.
Other fractions involved.
Of course there are.
No.
So I'm going to graph log base 1/3 of the quantity x plus 3 minus 4. Okay. First thing I do is I figure out where my asymptote's going to go. At -3, very good. My b value is bigger than 0, but it's less than 1, so this is going to be moving what direction? Down and right, so I know it's going to go down and right. So I have to pick out a value that'll create I need to add 3 to something that gives me 1/3.
Wait, isn't it like 8/3?
I don't know.
I think so, yeah. Because it's like 2 and 2/3, and then you add 3. Well,
So it's -2 and 2/3, right?
So 8. Negative 8/3.
So if I choose a value of x, -2 and 2/3. So what's log base 1/3 of a third? 1. What's 1 minus 4? So you get 1 minus 4, you get -3. So your ordered pair here was -2 and 2/3. Or if you want to write it as -8/3, that's fine. I think, okay, you know how much I absolutely loathe mixed numbers? There's very few occasions they make sense. This is one of them. This is one of them that make a little bit of sense. And then in about a week, we start talking about radians and finding reference angles. It's a lot easier to count 2 revolutions and 2/3 as opposed to 8/3. It's just easier to count that way. So your ordered pair was at -2 and 2/3, -3, here-ish. Okay? And now I need to create it again so that it equals 1. Yes, ma'am?
Why did you subtract 1?
Because what was log base 1/3 of 1/3? 1. And then what's 1 minus 4? What I'm doing here is I'm creating the log base b of b here. Because according to order of operations, it tells me that that equals 1.
Oh.
All right? I'm using the shortcuts to get to it. Okay. What was the other one I had to do? How do I turn? What do I use? -2. Next one I pick for x would be at -2. If I do the log base 1/3 of -2 plus 3, that gives me the log base 1/3 of 1, which is 0. And then so I get 0 minus 4, which means it is at -4. So it's at -2 and -4. And just like I said, it's moving down and right.
So even if you didn't know which way it was moving, by graphing it, you would know.
Unless you screw up the sign. Okay. So yeah, like I said, you can get fractions, but when you look at it, you're not really working a ton with them, and it's not gonna be log base.
7/16, please.
No, that's yeah, I'll do that. That's a good one. What if I do like 57/3?
I was surprised.
Let's try it.
Let's do this.
Try it like
I can do this with hands.
Ooh. Natural log of x plus 2.
minus 2 e squared.
All right, so in this case, we have to revert back to remembering what does natural log stand for? Log e. So this is the same thing as saying log base log base e of x plus 2. What's my h? So it is 0. I have vertical asymptote at 0. Okay. My domain x such that x is greater than 0. If you just want to write domains x is greater than 0, it's fine. I'm just being fancy with my set notation, trying to act cool.
That is really cool.
Said the word try. I know. Yeah, I know, all right. Here too.
I wish a graph paper was that colorful.
That'd be cool.
That'd be more fun.
I agree. And then, so that means I have to figure out, I need to pick a value of x that gives me log base e. So x would equal e. So here's what we have to think about.
Yes.
If I choose a value of e, what's log base e of e? 1. What's 1 plus 2? 3. So that means I have an ordered pair at e 3.
Where, how do you graph E?
It's 2.7.
Yeah.
If you know 2.7, you're fine. Okay? It's actually B3, but that's okay.
You don't have to use the word. You can use
Eggnog? What if you say G though? What happens?
Yeah, that's
free for all. Just put it wherever you have the number.
Okay? So here, you can use E to make it work. If you remember that E is approximately 2.7, here-ish. It's there-ish. Okay? And now I need to get to the other one. I'm going to pick 1. What's log base E of 1? 0. So what's 0 plus 2? Oh, this is at 3. Sorry. It's going that way. Because base E is bigger than 1, it's increasing to the right. So is it okay if I give you E? If you remember that it's 2.7? Yeah, so the test-wise then, remember, we'll have exponential growth, decay, PERT, things like that. So, when do you use PERT?
When it's increasing, like continuously.
Yeah, continuously is when you use PERT. I'm almost done finishing up, making up a review thing for you guys for it. The only thing I didn't have was extra word problems. So what I might just do is just say, hey, relook at these in the book type of deal. I won't be in class tomorrow at all because I will be down for the NHS stuff all day. But I will be around tomorrow morning. In case you guys got questions, I'll be up in the room before school. And I'll do the same thing on Thursday. I'll be in the room before school on Thursday as well. Because are the assemblies this Thursday? Is it Thursday, Friday? I thought it was 2 days for some reason. Anybody know?
Wait, is it Monday and Friday? Or Friday and Monday?
I thought it was
Yes, it is.
Friday, Monday.
No,
That's my
Hey, is it possible that we might be able to look at like you guys have like the announcements or something? Don't they tell you that?
We get an email every day.
Oh, check the email. To the email machine.
I've got it pulled up. Hang on. Oh my gosh.
You know what turned 25 years old yesterday? Homer at the Bat. My absolute favorite Simpsons episode. best one ever.
Come here, Joe.
Yes, ma'am.
I go to sleep.
Yes, ma'am. Yes, ma'am.
You just take a flex test and you go for the game. Wait to make sure like no one's gonna come get you during flex.
Can I have flex passes for Marcy?
I won't be here tomorrow.
It doesn't check the
Okay, I'm
It says whoever's flexing out, go. Nobody's go.
I missed the homework.
You missed the homework?
What is the only one?
Let's see. So 70. So 69, 76.
Tired. I honestly just think
Do those, please. Give me a sec, and I will. Yeah. I will put it back up on the board here in a second. Skip 72. I didn't realize I threw that one on there. When I talked to, you can just wing it on regular paper, it's fine. When we were working on them in second hour, you actually had to generate values of multiple values of E to make it a graph work. I would not make you do that. The only time I would have you guys worry about graphing with E or with the natural log stuff is not giving you an H value with it. So it'd just be the natural log of X plus 6. All right, I will not have you ever worry about shifting it with the H involved with it. Okay, is that fair?
Yes.
Because then you have to say that it's if it's quantity X minus 2, then you have to figure out what, like 2E minus 2, does it get you to E? Yeah, that's just awful. Yeah, I will. I just want to get everybody to get this first.
Rouse is like the head guy. Big the advisor. I have him soccer, so. He's a.
Yeah, do domain range.
How do you find the range?
All real, because it's increasing to the right. It's all real. Yeah, your range is all real.
Okay.
All right, I might have forgotten to say that. Hey, your range for logs is all real.
What's the homework?
I forgot. Does that help?
A lot.
Well, what did it say on your hand?
I bet with your power of deductive reasoning, you may or may not be able to figure out which ones I want you to do.
How do you get off of this to figure out words?
Yeah, I put it there where you know this. Yeah.
Oh yeah? Look what I can do.
No, I don't think so. It's weird that you
Life's
have
better.
What's up?
Like a work card.
Yeah, me. Shut this off.
You better sign it before someone takes credit for your artwork.
Yeah, right?